forward to hearing from you. So it's all yours.
Okay, I'll start by sharing my screen. I'll just need a second. Is my screen visible? And is the font size right? Do I need to increase it?
Oh, that's good.
That's good.
Okay. I'm Yanis. I'm working mostly on all things related to Java and Kubernetes. And today I would like to talk about the recent developments in Quarkus around the service binding operator. Oops, sorry. Now, the goal here of this presentation and this talk is to try and get us as close as possible to work closely together so that we can get feedback for the things that we are building, but also, share our experiences with the service binding operator. I think that Quarkus doesn't need an introduction, so I'll just say that for us it is really important to provide the best possible experience to developers, both locally and on Kubernetes. And for that, I think that the service binding operator can play a very important role because I feel that it can immensely improve the experience of users, especially the ones that are just trying out Kubernetes and OpenShift and can improve their onboarding experience. So we already have implemented workload projection support. This is available since a while now. And we recently started playing with the generation of the service binding resource that is used by the service binding operator. It's worth mentioning that in the Quarkus ecosystem, we do have extensions that are related to Kubernetes. For example, we have extensions that are generating Kubernetes manifests. They hook into the Quarkus build process and extract information like ports being used, metrics endpoints and stuff. And they try to provide the best possible Kubernetes manifest so that Quarkus users can have a very smooth experience on Kubernetes. The generation of the service binding resource is going to be the first of the things that I'm going to share with you today. So let me get started. I have pre-created a kind cluster on my local machine, and I have installed the operator lifecycle manager. I've also have pre-installed the service binding operator and the crunchy data Postgres operator. For the sake of this presentation, I'm going to create a fresh namespace. Make sure that I'm on a clean environment. Sorry about that. The namespace already exists. Let me just drop that, just to make sure that I don't have trash from from rehearsals. By the way, is the font of my terminal visible, or do I need to increase it?
Please increase this font size a little.
Better?
Yeah, good.
Okay. Okay. For the next part, I'm going to apply a resource which is used by the crunchy data Postgres operator in order to start a Postgres cluster. I stole that resource from the service binding operator GitHub repository, which was part of the quick starts. So it may look familiar. And I'm going to apply it to my local cluster. And then I'll move on with a Quarkus application. Now, since the time is limited, I won't create an application from scratch, but instead I'm going to clone the Quarkus quick starts, and I'm going to pick up one of the quick starts to use in this demonstration. More specifically, I'm going to pick up the Hibernate ORM Panas quick start, which is pretty much a web application that implements a CRUD for foods. I've copied the directory, and what I'm going to add to this example is I'm going to add the Kubernetes extension for generating Kubernetes manifests, the Kubernetes service binding extension for the workload projection support and the generation of the service binding resource, and the container image Docker for performing an actual build. Everything is set. I will just configure my image pool policy because I will be using an image that's not publicly available. And as a last step, I'm going to start the container image build, and I'm going to load the image to the cluster. The final step is to proceed with the service binding related configuration. In order to have the Kubernetes service binding extension generate the service binding resource for me, I need to provide a minimal configuration, and that configuration is pretty much the coordinates to the Postgres cluster resource that I showed in one of the previous slides. So I need to specify maybe it's too much. Maybe that font size is better. I need to specify the API version, the kind, and the name. And I will pick those things up and will add it to my application.properties. And I'm going to trigger a new build. And I will also request a deployment to Kubernetes. By running this command behind the scenes, I will have a Kubernetes manifest generated for me. And as part of those Kubernetes manifests, I also have the service binding resource generated. The configuration file that I used is this one. You can see that in the lower left side of my screen, and I have highlighted the service binding configuration. And on the top side of my screen, you can see the generated resources. And I'll search for all the available resources that have been generated. I have a service, I have deployment, and as promised, I also have the service binding resource that pretty much binds our application to the service that we configured. And if I hadn't done anything horribly wrong, I should be able to verify the installation and port forward the HTTP port to my local port 8080. And see the application run. So what we are currently seeing is the web interface of the Quarkus quick start that I used. And this quick start is being connected to a Postgres database through the service binding operator. Let me make sure that everything works great. I'll add a blueberry. And I also going to drop the apple. By the way, apples doesn't work. At least it didn't work for me and COVID. So I'll drop them. And I can now disconnect. We have any questions so far?
Oh, that's great. Thank you.
Okay. I would like to take things one step further, and I would like to further improve the user experience. And the way that I see things, it would be magical if we could provide the exact same experience, but without requiring from the user to add those 3 service binding related lines. So I feel that it would be magical if the user didn't have to know about the Crunchy data operator, which is the API group and API version and all those things that are mostly feel like DevOps related stuff. So I've been working on what I call automatic service binding generation, which tries to take advantage of the Quarkus build system. So from the Quarkus build system, it can detect things like, hey, what are the available data sources that are part of the application? What are the Kafka connection the application is using? Do we have any Mongo client and things like that, combined with the knowledge of the operators that are currently supported as bindable by the service binding operator. So by combining these 2 pieces of information and using a smart set of conventions, which I will cover a little bit later, we are able to provide the same experience without having the user to manually configure everything. And I will try to demonstrate that now. So remember that in our configuration file, we have those lines that are related to service binding. And I would like to drop them. They are gone now. Do I switch between workspaces too fast? Can you follow what?
No.
Okay.
That's fine.
Okay, so the configuration is dropped, and I'm rebuilding the application. And what I expect to see here is the generated Kubernetes manifest, not including the service binding resource. I verify or search my file for all the available resources, and I only have a service and a deployment now, no service binding. I will switch from the latest Quarkus release to a snapshot version of Quarkus, where I'm experimenting with the automatic service binding in order, to rebuild the app and see if I can get the exact same service binding generated with 0 configuration. And if everything went right, yeah, they should be able to see the service binding being back without having any service binding operator related configuration. I don't think that it makes sense to perform the same process again and redeploy everything, since the generated service binding is 100% the same with the one that I showed in the previous step. Now, can we get things even better? So for the happy path where the user doesn't need to perform any kind of customization, I think that we've reached the best possible experience. The question is, what happens when customization is needed, right? So for example, one of the conventions that we used was that the target resource is named the same as the type of the database that we are using. So for example, we require it to be called PostgreSQL. But what happens if the users have deployed a database that is called FruitsDB or something like that? For cases like that, we are able to do some customizations using properties like the ones that I demonstrated in the first part of the presentation. But we also have additional conventions, like, for example, if the user, instead of having a generic data source configured in the application, uses a named data source, we will take the name of the data source and try to correlate it with the installed Postgres. Again, this experience is not ideal, and in my opinion, the best thing that we could do is to provide an experience that would be completely agnostic of operators. So, for example, an experience that would have absolutely no requirement of the user bringing in information like API groups and versions, custom resource names, and things like that. Something like that, the way that I see it, could possibly work just by expressing with the use of something like labels or something like that. But we just need a connection to a database of type Postgres with possibly additional labels like the version of the database, or maybe even additional qualifiers like the name. But absolutely nothing related to the actual target operator. I feel that this is something that the service binding operator could find, since it's running already on the cluster. It could detect which are the databases that are available and hook that to us. And
So may I answer now, or you prefer to continue?
No. I think that with this suggestion, let's say, we have the perfect opportunity to bootstrap our discussion.
Okay, wonderful. Thanks for doing this demo and for preparing the materials and so on. I definitely think that it is perfect, and would love to put that under our documentation, but maybe it's also something that we can publish as a recorded video or recorded demo for SBO, because I think the flow is really smooth. It's good for Red Hat in the sense that it shows SBO plus Quarkus. So maybe we can leverage that for marketing purposes. Your feedback related to automatically binding, I think is completely fair. So we have been working a little bit around those lines in the context of OpenShift Developer Console and in the context of Audio as well, where you have the ability to list what are the different services that are already available on the cluster, which are known as bindable services, that you as a user has the permission to bind your application to. So this is where we are heading. I do believe that the capability is supposed to be in 4.10 in the UI of OpenShift Developer Console. And for Audio, in fact, it is in some ways it is already available, because you do a catalog list where you see the different databases that are available, and then you pick one that you want to connect to. When you do the link command, you just say to which database you want to link to. So what we did, and Predrag, you can keep me honest on this, is that we built an API once the operator is available that is giving the list of those bindable services. So it's probably something that you could connect to as well in the client.
Yeah, I mean, you can discover those bindable services. So if, for example, in case of Crunchy, Crunchy operator and the others, if there is some instance in your name, well, there you can discover it by doing some queries against the Kubernetes API. But again, you have to do it like from the Quarkus side or from some other side, and then create proper service binding. That's really possible. I like the idea of. By the way, Yanis, so I know that you shared with me the link previously to the blog post, and I think the blog post is practically what you have shown us today, right?
On the first step, it's pretty much.
Okay, so the second step is missing. Okay, good. Okay.
Yeah.
No,
the second step is things that I'm working on locally, and they haven't even made it upstream Quarkus yet.
Speaking of this Automagic, I like it, but my question would be more like, do you think, or would it be valuable to create such bindings without talking to a cluster where, for example, some service operator is running? So I imagine, for example, in case that when you have a cluster where Postgres operator is running, and you say like from Quarkus application, okay, I need to connect to some Postgres instance, and I have a cluster I can talk to, I could discover exactly what's the name of that instance. So it doesn't have to be any convention there, and then you could create proper service binding. So do you think that you can, I mean, contacting cluster would definitely give you more information, and where you can actually know exactly what's the service name or what operator is available, so you can actually use proper service binding. But without contacting cluster, do you think that you can reach what you want to reach?
I think from my point of view, the ideal situation would be to just specify something like the qualifiers, or something like a label selector or something like that, and have the actual job being performed by the service binding operator. The main reason is that we want to avoid having to talk to an actual cluster, because the experience we had when we were working on tools like the Fabricate Maven plugin and stuff, were that whenever we generated things based on what was available on the actual cluster, it unleashed many issues. So we would like, let's say, to ensure that the things that we generate for a single application are exactly the same, regardless of the environment of the developer that actually ran the generation code, if that makes sense.
Yeah, so somehow to declare dependencies to your services without, in a very generic way, like as you said, I need a Postgres database in version something X, and that's it.
Yeah, that rhymes with what Java developers are already used to, because Java developers using version of control all the time, and they have things injected to their app all the time just by specifying the type and maybe the name or other qualifiers. So I feel that the ideal experience to provide to our users would be a similar experience. Just describe what we want and have it injected to us.
Ioannis, I have a question as well.
Yeah.
So thank you for the demo, by the way. We used to have we had a bit of a chicken and egg problem before, where we couldn't create a service using Quarkus that depended on the database until the actual database was there, and on the other hand, we couldn't do the service binding until we actually had the service deployed. So I didn't catch that 100%. You did run the deployment twice when you run it, didn't you? Or is this? Or can
I actually ran the deployment once. I only ran the generation part a second time, or at least I think that I did.
So
it doesn't matter.
basically, my question is
from what I see, we can run this code and perform the actual deployment without having issues, even if the database is not there. So even if the binding is failed, everything else works fine. And I even think that it is possible in case we have multiple services to bind, that if one binding fails and the other to succeed,
I guess
without affecting.
I guess one thing we didn't see here, whether you're like before the actual service binding happening, do your application, because if the application starts, the pod starts before there, it wouldn't start because it wouldn't have a database connection, wouldn't it?
Yeah, it would fail in the database connection part.
Yeah, and but this way of doing it, I guess it will recover as soon as the database connection is up and running. It will recover as soon as
the service binding operator try to reconcile service binding resource in case, for example, if one of the parts, service or application is not there, you're gonna kind of back off and try to reconcile, it's an exponential back off. So eventually, when the database and service and application are up and running, you're gonna get connection and inject binding will be projected. It can take some time in some scenarios, right? But it solely depends on Kubernetes, right?
Yeah. Cool.
In my previous comment, when I meant that it will work even if the database is not there, or even if the binding failed, I didn't take into consideration what the actual application will do, right? And the application, when it starts up, it tries to initialize everything and populate the data to the schema. But if the app itself was using, let's say, lazily the database, it would completely work even if the binding or the database was not even there. What I'm trying to say is that the deployment manifest of the application is 100% perfectly valid and completely decoupled from the presence of the binding or the actual database.
I think Max wants to speak something.
Yeah, it was just now that Predrag, you mentioned this thing about being able to not contact the cluster to get information or something. One thing I find would be interesting, so that this is depending on the service binding operator to be present. But I wish we could do the same. I think Odoo has done it, where they run service binding operator as a library when it's not present, right? Didn't they do that?
Yeah, they do. Yeah,
that's correct.
So I wish we could do that here, because then we could use the binding spec to basically run this against any kind of cluster, whether the operator is there or not.
Just to clarify, the generation does not require the service binding operator to be present.
No, but
the binding to succeed.
It needs, it needs it, right? So what they do, and but what we have here, I think is great. That's as good as we can get at this first hand. It's just that what the Odoo guys did was that they literally load in the service binding operator as a Go dependency, and then they generate during deployment. I think they generate the stuff that the service binding operator would do. So I mean, it's runnable against clusters that doesn't have the operator. So which would be interesting, but that would require us to have like service binding operator as a CLI somehow, or as a Java client or something. But we can
WebAssembly.
Yes.
Yeah.
I don't see.
So
It's Is there any other ways we could address that?
So if Odo if SBO had a CLI, we could, if users had that in the past, we could do this trick.
But you could use, since you said you wouldn't need some CLI, then you could use Odeo as such CLI.
Yeah, but Odo I don't think Odo. Well, but Odo doesn't have don't be Odo mode, right? Odo has these assumptions of a layout that wouldn't be there. Right? I think, but yeah, it could be an option. Yeah. So
presumably that would only work when you initially deploy the app, though, and then if the nice thing about the service binding operator is,
of course, this has limits, but
yeah,
the bad thing about the service binding operator is it's an operator, meaning it's only exists in a very small set of community clusters out there. People won't have admin access, right? That's the so. But I'm just, this is just something I wish we had. I don't have a good. If we had this, we could use service binding almost everywhere.
Well, I saw Thomas here in the call, but probably he left. But I'm pretty sure that in some scenarios, Odeo CLI would be your friend in this particular case if you don't have a service binding operator available, because they are connecting some applications, and Quarkus application is the application, and you don't need to generate that. Then service binding, you can then tell only to Odeo, connect me to whatever database.
If Odo have a mode of literally just doing the connection and nothing else, and we can give everything in the command line, then yeah, we could.
Yeah.
So. Anyway, no, it's we just need more operators that we can rely on. That not operators. What's it called? Services. Yeah.
I think.
So,
by the way, just a question. Service binding operator right now is not depending on everything being an operator at the moment.
No, not at all.
Yeah. Is
Service binding operator is just the messenger between the service and application. So finds the binding and project the binding into application. It could be an irregular deployment. It could be just pointing to a secret. So it's just doesn't even try to interpret anything. What's inside of your binding.
and another.
And service binding operator can be also installed without OLM, so any plain Kubernetes cluster. So there is not any card requirement that you have to have OLM installed nor OpenShift, so it runs on any plain Kubernetes cluster.
And we are planning.
So in practice, then you could even install. So sorry. In theory, you can even install service binding operator in your own namespace where you have access to deploy things. So.
Okay. Yeah. The reason I
think that for Quarkus specifically, this is really important. The fact that it doesn't require anything OpenShift specific, at least for upstream Quarkus, right?
Yeah.
No, it's good. The reason I'm asking is just sometime this year I was curious if we could have an example of actually exposing a Quarkus service as a service binding. But it sounds like we should be able to do that, so that's good.
That would be cool.
So yeah. Oh,
and for Quarkus as a product, we are still planning to ship service binding operator by default with OpenShift as well. So once we have the bits that we need from OpenShift, that's something that we are planning to do.
Cool.
It solves part of the problem. Small one, I know.
I think so I'm working on the Strimzi service that service binding operator would connect to. And I think from our point of view, it would be an interesting idea if an application could be deployed with a service binding request that didn't have the name of the service in it, it only had the kind and the API, because the way we're doing it from Strimzy, at least, we're setting up with the expectation a lot of our users run Strimzy in one namespace and they run all their apps in a different namespace. So we've added an additional custom resource definition, with the idea being that you have your main Kafka over here, and then in the namespace where you want your apps to be, you deploy a new CRD that says Kafka access is going to be called, that basically says this gives you access to this Kafka, this is where it lives and stuff. So actually, if you deployed your apps, the idea is there would just be that one service for you to bind to.
Yeah.
So you could come up and say, I just need a Kafka access.
That's I'm smiling because it is exactly what we have been discussing yesterday during one of our planning session, where we want. So to me, that the use case that you are describing is I need a better abstraction between a service binding that I am going to create into my developer environment and how that is going to look like in other type of environment or for another user or another developer. So there is not enough abstraction, because in the service binding itself, we provide those kind of data that are very specific to a single service. So yeah, it's something that we have identified as well, and that we want to work on.
I want to make sure, what name are you, like, for me, it's a nice thing that on the OSI we just say this type and this name, right? The name is basically what we are, like the thing we want to use as the name, right? You talk, what is the piece you don't want to have there?
No, I mean, it's not that we don't want to have it. It's just that we want to be able to have a mechanism that is abstracting those information when you are replicating your application onto a different environment, because most likely your service binding is going to be part of your application definition.
Yes.
But maybe the service name is going to be service A into one environment and service B into another environment. So that means...
Sure, but okay, maybe I'm missing something, but from the client side, we don't specify what you call it. That is something the service binding operator could do. Right?
Yes, but today it does not. You need to specify the name.
We should be just very careful not to slip into the service discovery land, because service binding is not about discovery. It's just about binding two pieces together. And what I'm hearing now, we are kind of willing more to have a discovery like we used to have before, like just specifying type or some other, properties of a service, and then you get a connect like a reference to the service. And we could have another operator dealing with that. For example, in case what Yannis presented, instead of we can declare, as he said, dependencies, but in this kind of abstract way for discovery. Like I need a Postgres database in a version X and some other services. And then there is another operator which actually just look at the application deployments and then try to find out, okay, is there like services according to whatever contract we want to have? And then that operator can create service binding. So you don't even need to deliver service binding upfront. So we should also start thinking about that. Application doesn't need to deliver all the pieces. For example, not services. Service could be managed, could be provided by some other parties. What you're delivering is the application and new kind of express dependencies you need to have in the cluster that you can run your application. And service bindings is very explicit dependency, but you can make it more declarative in the sense that somebody else would find services and create service binding for you at the runtime.
I get what you're saying about not getting into the service discovery territory, but I'm wondering if instead of having to specify the coordinates as in an API group and version, a kind and a name, we could specify the target resource with a label selector or something like that.
Yeah, we
And,
could. Yeah, I mean, we could think
and
about
of course, a solution like that wouldn't put additional loads to the service binding operator, because it would be, for the service binding operator, it would be a pass-through, right?
Yeah, no, definitely, we could do that. We could kind of relax naming and make naming more abstract, so that you don't need to know exactly what is the operator installed there. Just saying that we need to know where is the border, like not to really do service discovery as well.
Yeah, I think that's what I'm suggesting is a good compromise, and doesn't get you into the dangerous territories, or in any way in areas that you don't want to delve.
Yeah.
So
We can even do like a GNDA lookup at runtime if we want. Like that's very popular in the last weeks.
No.
You mean a GND lookup for Log4j? Is that what you meaning?
Yeah.
So what I propose is that we debrief a little bit on that and see what kind of solution could emerge. So maybe next week we can follow up.
Okay.
Yeah.
So just a quick question. Next week also, do you want the same time or the regular time?
Let me check, because it's planning week.
Okay, fine.
No, that's good. That's good for me. We can get back to the usual time of 2 p.m. if that works for everyone.
Yeah.
Thank you. Thanks, everyone.
Thank you.
Thanks a lot. Yeah.
Thank you.
Thanks, everyone.
Thank you, everyone.
Thank you. Bye.
Yeah. Bye.
Thank you, everyone.